The universe is one-way doors. Black holes, white holes, and the deepest mysteries of space. Imagine standing at the edge of a waterfall so powerful that even light, the fastest thing in the universe, could not escape once it crossed the brink. That is a black hole. Now flip that idea inside out. A place where things can only come out, never go in. That is a white hole. They sound like science fiction, but both come from real physics, equations so powerful they describe the universe itself. And sometimes, disturbingly, go beyond what we can truly understand. The birth of darkness. What is a black hole? A black hole is not a hole in space. It is a region where gravity has become overwhelmingly strong. So strong that nothing, not even light, can escape once it crosses a boundary called the event horizon. At the center lies the singularity, a point where matter is crushed into infinite density, and the laws of physics as we know them break down. Most black holes are born from the death of massive stars. When a star runs out of fuel, gravity wins. The star collapses inward, and if it is massive enough, it forms a black hole. But here's something even stranger. For all their complexity, black holes are shockingly simple. According to the no-hair theorem, a black hole can be completely described using only three properties: mass, electric charge, spin, angular momentum. Everything else about the original star, its color, structure, composition, is erased. It's as if the universe takes something incredibly detailed and reduces it to a three-number summary. A reality check: they don't suck everything in. Black holes have a reputation for being cosmic vacuum cleaners, but that's not quite true. From far away, a black hole's gravity behaves just like any other object with the same mass. If our sun magically turned into a black hole, Earth would keep orbiting just as it is now. Small but important detail: we would lose sunlight and freeze solid within minutes. Great for orbital physics, terrible for everything else. The danger begins only when you get too close. Falling in. A one-way trip. Crossing the event horizon is like stepping through a door that locks forever behind you. Inside, escape is impossible, not because something is pulling you back, but because all paths through space lead inward, and things get uncomfortable. As you fall, gravity stretches your body in a process scientists call spaghettification. But here's the twist: that dramatic stretching depends on the size of the black hole. In smaller black holes, it happens quickly and violently. But in supermassive black holes, the gravity at the event horizon is more spread out. You could cross it without even noticing, at first. Unless, of course, a different theory is right. Some physicists propose the firewall paradox, which suggests that quantum effects could turn the event horizon into a wall of high-energy particles, instantly incinerating anything that tries to pass through. So your options are slow stretching into spaghetti, or instant cosmic vaporization. Not exactly comforting. The spinning reality, ringularities and cosmic whirlpools. The singularity is often described as a point, but that's only true for a non-spinning black hole. In reality, most black holes spin, because the stars that formed them were spinning. These are called Kerr black holes. Inside them, the singularity becomes a ring, a ringularity. And here's where things become truly mind-bending. Some solutions of Einstein's equation suggest that instead of hitting the singularity, it might be possible, at least mathematically, to pass through the ring. These ideas are part of what fuels theories about wormholes, white holes, or even pathways to other regions of spacetime. Surrounding this spinning structure is the ergosphere, a region where space-time itself is dragged around like a cosmic whirlpool. Even before crossing the event horizon, you would be forced to move with the black hole's rotation. The universe doesn't just pull you in, it makes you spin along with it. The photon sphere, a cosmic hall of mirrors. Before reaching the event horizon, there exists a bizarre boundary called the photon sphere. Here, gravity is so strong that light itself can orbit the black hole. Imagine standing there, which, again, would be a terrible idea. If you looked straight ahead, you could theoretically see the back of your own head. Because light reflecting off, you could travel all the way around the black hole and return to your eyes. A mirror, made entirely of gravity. Are black holes real? Yes, completely. For decades, black holes were just predictions from Einstein's equations. Even Einstein doubted they existed. But the universe disagreed. In 1971, Cygnus X1 became one of the first strong black hole candidates. In 2015, gravitational waves from merging black holes were detected, ripples in spacetime itself. In 2019, scientists captured the first image of a black hole in galaxy M87, a glowing ring surrounding a dark shadow. That image looked like a cosmic donut, and instantly became one of the most famous scientific images ever. Today, scientists believe that nearly every galaxy, including our own, contains a supermassive black hole at its center. The brightest lights from the darkest places. Here's a beautiful contradiction. Black holes can create the brightest objects in the universe. When matter falls toward a supermassive black hole, it forms a swirling accretion disk. Friction heats this material to extreme temperatures, making it glow intensely. If the heating becomes extreme, the result is a quasar, an object so bright it can outshine entire galaxies. And quasars don't just shine, they can shape the fate of galaxies. The enormous energy they release can blow away the gas needed to form new stars, effectively shutting down star formation. They are not just bright, they are cosmic regulators. A gentle glow. Black holes aren't completely black. In the 1970s, Stephen Hawking discovered something astonishing. Black holes can emit radiation. This Hawking radiation occurs due to quantum effects near the event horizon. Over incredibly long timescales, black holes can slowly lose mass, and eventually evaporate. So even the universe's ultimate traps may not last forever. The information paradox and the holographic universe. This leads to one of the biggest mysteries in physics, the information paradox. If something falls into a black hole, is its information lost forever? That would break a fundamental rule of quantum mechanics. To solve this, physicists like Leonard Susskind proposed the holographic principle. According to this idea, everything that falls into a black hole is not lost. It is encoded on the surface of the event horizon, like a two-dimensional hologram storing a three-dimensional reality. The universe, it seems, may never forget anything. It just hides the data in unexpected places. Now flip the script. What is a white hole? If a black hole is a one-way entrance, a white hole is a one-way exit. A white hole is a hypothetical region of space, where matter and energy can escape, but nothing can enter. They arise naturally from the same equations that describe black holes. In a sense, they are time-reversed versions of black holes. Where black holes consume, white holes eject. The problem, we've never seen one. Unlike black holes, white holes remain purely theoretical. There is no direct observational evidence that they exist. Why? They appear to be extremely unstable. They may violate thermodynamic laws. There is no known natural way to form them. They are allowed by mathematics, but not yet confirmed by reality. Wild possibilities. Do white holes exist? Even so, scientists haven't given up on them. Some ideas include black hole-white hole transition. A black hole might eventually bounce and release its contents. Wormholes. A black hole could connect to a white hole elsewhere in space. The Big Bang. Some theories suggest our universe itself might resemble a white hole event. It's speculative, but fascinating. The missing middle, a cosmic mystery. Here's a quieter puzzle. We've observed small black holes from stars, giant black holes at galaxy centers. But for a long time, the middle-sized ones were missing. Now, we are just beginning to find clues. In 2020, gravitational wave detectors observed an event known as GW 190521, which produced a black hole about 142 times the mass of our Sun, falling squarely into the intermediate mass range. It's like finally spotting an animal between ants and elephants. The mystery isn't gone, but it's starting to crack open. Final thought: the universe is stranger than we think. Black holes are real. They warp space, bend time, and hide their secrets behind invisible boundaries. White holes may or may not exist, but they remind us that the universe is not limited by our intuition. A century ago, black holes were just equations. Today, we photograph them. So perhaps one day, somewhere in the vast darkness, we will witness something erupting outward. A cosmic fountain of light and matter. A white hole. And when that happens, the universe will whisper the same message it always does. You still don't understand me, not even close.
It's time to study new words in context. 1. Brink. Definition: the very edge or the point just before something happens. Example: she stood on the brink of the cliff and looked down. 2. Equations. Definition: math sentences that show two things are equal. Example: students learn equations like 2 plus 2 equals 4 in school. 3. Singularity. Definition: a point where things become extremely dense, and normal rules no longer work. Example: scientists say a singularity exists at the center of a black hole. 4. Angular. Definition: related to angles or turning movement. Example: the dancer made smooth angular movements with her arms. 5. Spaghettification. Definition: the stretching of an object into a long, thin shape like spaghetti. Example: in space, strong gravity can cause spaghettification of objects. 6. Quantum effects. Definition: strange behaviors that happen at very tiny levels, like atoms and particles. Example: quantum effects can make particles act in unusual ways. 7. Incinerating. Definition: burning something completely until it turns into ash. Example: the fire was so strong that it started incinerating everything inside. 8. Ringularities. Definition: ring-shaped centers of spinning black holes. Example: some scientists believe ringularities may allow matter to pass through. 9. Whirlpools. Definition: spinning movements of water or air that pull things inward. Example: the boat was pulled toward the whirlpool in the river. 10. Mind-bending. Definition: very surprising or hard to understand. Example: the movie had a mind-bending story that confused everyone. 11. Ergosphere. Definition: a space around a spinning black hole, where everything is forced to move. Example: inside the ergosphere, nothing can stay still because space itself is moving. 12. Bizarre. Definition: very strange or unusual. Example: he had a bizarre idea that no one else understood. 13. Accretion. Definition: the process of gathering or adding more material over time. Example: the planet grew larger by accretion of dust and rocks. 14. Quasar. Definition: a very bright object in space powered by a black hole. Example: the quasar was so bright that scientists could see it from far away. 15. Holographic. Definition: showing a 3D image on a flat surface. Example: the museum used holographic displays to show ancient objects. 16. Thermodynamic laws. Definition: basic rules about how heat and energy move and change. Example: thermodynamic laws explain why heat flows from hot things to cold things. 17. Speculative. Definition: based on ideas or guesses, not proven facts. Example: his theory about aliens is still speculative. 18. Warp. Definition: To bend or twist out of shape. Example. Heat can warp plastic and make it change shape. 19. Intuition. Definition. A feeling or understanding without needing to think deeply. Example. She used her intuition to make a quick decision.
Comprehension questions. 1. What is a black hole? Answer. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. 2. What is the event horizon? Answer. The event horizon is the boundary around a black hole where nothing can escape once it crosses. 3. How are most black holes formed? Answer. Most black holes are formed when massive stars collapse after running out of fuel. 4. What 3 things describe a black hole according to the no-hair theorem? Answer. Mass, electric charge, and spin. 5. What would happen to Earth if the Sun suddenly became a black hole? Answer. Earth would keep orbiting, but it would freeze because there would be no sunlight. 6. What is spaghettification? Answer. It is the stretching of an object into a long, thin shape due to strong gravity. 7. Why might you not feel anything when crossing a supermassive black hole's event horizon? Answer. Because the gravity is more spread out, so the change is not sudden at the boundary. 8. What is the firewall paradox? Answer. It is a theory that the event horizon could be a wall of energy that burns anything that enters. 9. What is a ringularity? Answer. It is a ring-shaped singularity found inside a spinning black hole. 10. What is the ergosphere? Answer. It is a region around a spinning black hole, where space itself is dragged and everything must move. 11. What happens in the photon sphere? Answer. Light can orbit the black hole, and you could theoretically see behind yourself. 12. What is a quasar? Answer. A quasar is an extremely bright object, created by a black hole pulling in matter. 13. How can quasars affect galaxies? Answer. They can blow away gas, stopping new stars from forming. 14. What is the information paradox? Answer. It is the question of whether information is lost forever inside a black hole. 15. What is a white hole? Answer. A white hole is a theoretical object where matter can only come out, not go in. 16. Why are white holes still uncertain? Answer. Because there is no real evidence, and scientists do not know how they could form. 17. What is the missing middle black hole mystery? Answer. Scientists have found small and large black holes, but intermediate ones are rare and hard to find. 18. What discovery gave evidence of intermediate mass black holes? Answer. The 2020 gravitational wave event GW190521. 19. What does it mean to warp space? Answer. It means to bend or change the shape of space. 20. What is the main idea of the article? Answer. The article explains black holes, white holes, and the mysteries of space, showing how strange and complex the universe is.